Hello, welcome to my channel once again, and today I am going to talk about scatterplots. So sometimes you might have a data set and the data set contains continuous explanatory variables. So the best thing you might want to do is to explore the relationship between or the association between the variables. And this video is going to show you how to do that. Now, let's get started. I have already showed you how to, in the previous videos, how to import a data set, how to view them, how to attach them, and how to know the columns of the data set. So basically, this is the same thing we are going to do right here to view the first data set we are going to do. So the first data set is telling you that we are going to read the data set from, and the name of the data is scatter1. The heading is true, and it tells you that the names of the columns are already there. This one is going to view the data. This is going to attach it so that calling the names becomes very easy, and you're going to know to read the names of the columns. So let's run them one after the other. We read it, we view the data, and it's telling you that they have 2,000 entries with 2 columns. And what are the, then we attach it. So after attaching it, what are the names of the columns? That is where we use the names to do that. And then it tells you that it is, the first column is called X, V, and then Y, S. So the S column, this is the S column, and this is the Y column. So basically the X column is called the explanatory variable, and then the Y column is called the response variable. So one thing is that you might want to produce a Cartesian plot function. That is a scatter plot for that. We have another one called regression, where we regress the Y on X, and it still produces the same thing. But let's focus on the Cartesian plot function. So by doing that, I'm going to show it to you very, very simple over here. So we are going to, like I said already, we are going to produce a scatter plot using the Cartesian plot function. We plot it. We use the plot function, and then this is the X variable, that is the explanatory variable. This is the response variable, that is the Y. Then we use a color. So we call for a color, and we are using the rainbow colors. You can choose any color. We are using the rainbow colors. And then the PCH is called a plot character, and we are using 20. So we do that, and then it produces everything nice over here. So the best thing you might want to do is that you don't want to use this name as YS, and then you don't want to use XV. And then sometimes you might also want to use a heading for that. So I am going to show you how to do that. That is by renaming the, changing the names of the variables in the same plot. So what you want to do is that we do that over here, nice over here. So we are going to plot it over here. By plotting it, this is the X variable, that is the explanatory variable. This is the response variable. We are changing the color to green because we are going to plot another function, another scatter plot on the same plot. So we are going to change it to green. And then the plot character, we are using 20. We change the X name to X lab, and then we say it is called explanatory variable. And then the Y lab is the Y variable, which is going to be called the response variable. And then we use main as the title, so scatter plots. So now let's run it and see. It gives us something nice over here, but you see that because we didn't specify the limits, it is giving us something over here, and this is very strange with 2,000 entries. So with time, I'm going to show you how to do that by using the X limits. But before that, we can't specify it right now, but let me show you why I will show you why it's not good to do that right now. So now another thing that we want to do is to draw a regression line through the cloud of data points over here, and we use a function called outline. So we use the outline function. So we use the outline function over here, and then we call it on a linear model. So this is a linear model. Then we regress the response variable on the explanatory variable, and it is going to help us draw the regression line. So We do that, and it gives out the regression line. The regression line, it's telling you that it's also called the line of best fits. Actually, we were expecting all the data points to line on the regression line, but because of variations, it is giving us it is plotting them anywhere during that. When we get to regression, I will explain everything so that you understand better. So another thing we want to do is that once we are done with this, sometimes we also have another data set, and we also want to plot the same scatter plots on this same graph. So what we want to do is that we are going to import the data, attach the data, view the data, and then and then call for the names of the data. So we do that. Let me give more space over here so that I can paste code over here. So we are going to add more points to the data. So what we want to do is that we read the data, we attach the data, we view the data to see the observations of the data, and then we look at the names of the columns. So we run it, we run this one too, we run by viewing it, and it is telling you that they have only 250. The first one has 2,000 entries, and the columns are 2. This is XV2, and then there's a code to read that, and it is very, very simple. You do the names, and then you call for the data. So the data is called data 1. So you do that, and it tells you that we have XV2 over here, and then we have YS2 over here. That is the response variable, and then this one is the explanatory variable. So what we want to do is that we will also want to add more points to the function. So what we are doing, the first one, we use plot function, right? But here we are not going to do that. We use the plot function. If you use plot function on this one, it is going to give you a different graph. But because we want to do the graph on the same thing, we call something points. So we will want to use the points to do that. And let me show you how you can do that. This is very, very simple thing. So you might want to also do that here. So you call it points, and then this is the name of the categorical the explanatory variable, which is the X variable, and then the Y variable is the response variable. It's also here. The names are already here, and then the color we want to change the color to a different color. So we use red, and then the PCH is 20. We don't need to also give the names for the Y and then the X and then the heading, because we want to plot it on the same graph. So we just leave it like that, and then we plot it. So once we plot it over here, it's very, very, very nice. Now, are you observing something from the data set? Okay, I will show you something. But before that, let's run the regression line to see through the extra point and see how we can also do that. And then by doing that, we add a regression line by using the same upline function that we use here. The upline linear model regress the response variable on the explanatory variable, and then we do that. It is going to draw the best line of fit for them. But the issue is that now let's look at it. So the issue is because the first data set has 2,000 entries, the best thing we could have done is to explain the limits, but we couldn't do that because we didn't know the second function, whether it's going to. So you can see that there are some data points going below this one. So the best thing to solve this one is by using ranges. You need to specify the range, that is the S lim and then the Y lim. I'm going to show you a code, and sometimes it works depending on the computer you are using. But here it is going to tell me that then the X variable and the Y variable, it's different. So we want to scale it so that it is going to show, we want to add a scale to it so that we will do that. But let me show you how we can do that over here. So we do that over here. We plot it, and this is the first. We use the concatenate function to call for the first data points, the second data point from the X and Y variable, then we use the limits. I will show you why I use 0, 0, and then 100, and I use 0 and then 70 for the Y limit. And then the explanatory variable is already here. The Y lab is also already here. And then the type is, we use something called type in. Let's run it and see. When you run it, it is going to tell you that the X and Y length differ. This is because the first data set here contains 2,000 entries, and then the second one contains 250 entries. Now, let me show you how you can do this. Still, you can still do it. The only thing is to specify the range between the X variables for the first data and the second one. Then you also find a range for the Y variable in the first data and then the Y variable in the second data. This is very, very simple. Let me show you how you can do that over here. So we call something range. So let me do that very, very simple over here. So we call for the ranges. If you find a range between the first one, the first X, second X, then another range between the second, the first Y and the second Y. So we do that. We run the first one. It tells you the ranges is between approximately 0 to 100, and the second one is running from from 13 to 65, 60, whatever. So what you have to do is, let's assume that we are running for the X limit to be 0 to 100, and then the Y limit is supposed to be 0 to 70. So the best thing you could do is by doing the best thing you could do is by drawing a new scatter plot with the limits, so that it becomes very, very easy, since we were not able to use the first code over here. So I'm going to show you that it is very, very simple. So we draw a new scatter plot so that we will specify the range as we move along. So we do the new scatter plots, and then we have almost the same thing. The only thing is that we use something called X limit, and then the X limit we use 0 to 20, 0 to 100, and then the Y limit 0 to 70. We got all these figures from here. So when you look at this graph, let's look at when we added the limit to it, what it's going to give us. So we do that, and then everything moves upwards a little, so that you can see all the data in them. So another thing you want to also do is by calling for the regression line, which we have already done. So I will just do that over here real quick, and then we run it. So when you run it, it becomes something nice over here, which I have already told you that the regression line is called the line of best fit. So now we will add the additional points by using the points function. So that one too, very, very simple over here. Let me give more space over here, and then come backwards and then put that over here. Then we do that. It shows you, it draws the line. Now you can see that they all fall within the range. So that is why we actually do that. So another thing we have to do is that we add our regression line to this extra points that we did that, and I have already showed you how you do that. That is the outline, the linear model YX2, which is a response regressing on, which we call this a tilde, regressing on this, and then we run this one too. When you run it, it gives you the plot over here. Now, assuming that this is a clinical trial data where we had the first data sets for the people with the first trial, and then this is the second trial, because for example, sometimes if you are taking a clinical clinical trial, in the first we take a lot of okay, so let's assume that we have people that we are going to give the treatment, and the people that we are going to give placebo. So we are just doing that, and then if you want to specify it right now, we use the treatment and the control. So that one we will use legends, and then this legend is help us to explain the difference between the 2 points of data, or the 2 clouds of data. So what you have to do is to use the legend. So by using that, let me show you how you can do that so quick. It is very, very simple. So you say legend, which is a graphics, and then what you want to do is to use the locator. So the locator is here, and it is also graphics. We use one so that it tells us where you want to put it, anywhere you want to put it. Then another thing you want to do is to call for the names of the points. The first one, let's say, is called treatment. So we say it's called treatment, and then the second one is called control. And then another thing you might also want to do is to add a PCH, because you want to specify which of the PCH we use. In both one, we use 20 and 20. So we say PCH to, we use concatenate function, sorry, and then it tells you that we use 20 and then 20. So after you have done that too, then you might also want to add the color. So because we use the color, the first color, so the first color was green and the second one was blue. So you use the color. So the color is going to give us green and then blue. So you say green, and then the next one, you put it in this, and then say red. Sorry, it's red. So after that, you run it. After you run it, it gives you it keeps you loading over here. So it tells you that go to the graph and then put it at anywhere you want to put it. You can put it over here. You can also put it over here. So the best thing is let's put it here so that we can read it so quick. So you just put it over here, and then it comes so quick. This is how we do scatter plots. And then if you're happy about this, don't forget to subscribe to my channel. Thank you so much.